Hey, hi all, welcome back to BRR Knowledge Center. So in this topic, we'll discuss about reference of a class. So in the earlier session, we talk about a variable of a class, instance of a class, right? And the difference between variable of class and instance of a class. Got it? Now in this topic, we'll talk about a reference of a class. So let us understand what is the reference for a class in C Sharp. Please observe, right? There is a class, right? Going to have one method and one variable, right? And when you're trying to create instances of the class, right? It's going to allow you to create instances using new keyword. Got it? I think let's take an example, right? I'm going to take an example, right? Class example, right? And I have a class here, right? And I have a same x equal to 10 variable. And inside of here, I have a static y, right? A main method, right? String of arguments, right? And here, right? So I'm going to create two instances. Example, e1 equal to new of example, right? This is one instance. That means e1 is instance of class example, right? Similarly, we are going to create another instance called e2, right? This is going to be another instance to the example class. So now when I say like console dot right line of right e dot e1 dot x right equal to e1 dot x and e2 dot x equal to e2 dot x. Understood? I'm just printing the e1 instance x value on e2 x value. When you run this, right, you will be seeing right x value going to be printed right with the value 10 because I've not done any modification here. We have two copies of variable x, right? In the memory it is available. So let us modify the variable value and see like whether it is creating two memory addresses or not. Because I'm just copying this stuff. I think it is fine. I think so far. I think we have already have that program here, right? I'm just copying this. Looking at here, right? Console dot read line. So when you run this, you will get right two same values. But don't think that two are referring the same memory, but two instances are having two different memories here. To prove this, let's prove that. I'm going to, going to change the value here. After I created two instances, what I'll do is I'm going to print this value, that's fine. And then I'm going to say e1 dot x equal to 50. That is, I'm just modifying x variable of e1 instance. Modifying x variable of e1 instance. Then I'm going to print again same statement. Whatever statement here, I'm going to print it here. Now when I run this, right, you will see that, right, in the first instance, first print, it is printing 1010. But coming to second, I just modified a value of e1 instance 50, right? It is separately printed 50, right? And remaining e2 instance carrying is same. That means two memories we have here, right? Even though same class, we are creating multiple instances, but every instance is having its own memory. Understood? So you can see the output, right? X variable of the E1 instance is changed to 50, and it will not change the X variable in the E2 instance. Let us get modify the E2 instance now. So what I'll do is, after printing this, right, I'm going to change E2 dot X equal to, this time I'll change it to 100. Modifying X variable in, right, E2 instance. Got it? Now I'll print it. Is it understood? Here I change it in the one location variable, this is another location variable. When I run this, right, you can see first one is same value printed because I have modified. And secondly, I just modified an even instance, hence it is only affected. Second instance variable is not affected. And coming to the part, I modified E2 instance value to 100, right? It is going to affect E2 instance, but not even instance. So this proves that we have two instances of X variable available in the memory. Understood? So X variable having two memory allocations as part of example class. Understood? Right? The point that you need to understand is that you can create any number of instances of your class. And for each instance, a separate memory allocation will be done. The memory allocation done for one instance is never going to share with other instance. This instance memory is not going to share with this memory instance. Understood? So this is what the beauty of object-oriented programming. You can say it is the security of object-oriented programming. Every instance is unique, unique itself, right? This is all about instance of a, reference of a class. This is all about instances, what we're talking about, sorry. This is all about, we're talking about instances. Understood? Okay. Look, if you want to talk about the actual topic here, reference, right? Let's talk about a reference of a class here. So let us talk about reference of a class in G sharp, right? So I have a E1 and E2 instances here, right? Okay. So E1 is an instance of a class, but E2 is a reference of a class. What I'm going to change is, right? I'm going to just remove this and I can say E1. Understood? E1 is instance of a class, and here E2 is a reference of a class. So first one, it is initialized with a new keyword, hence it is instance, right? And second statement, E2 is not going to initialize with a new keyword, hence it is not an instance, but initializing with an existing instance called E1. That's why it is a reference. Okay. So the point that you need to remember is whenever a copy of the class is initialized with an existing instance, then it is called as a reference of a class. Here, E2 is initialized with the existing instance E1, right? This is, right? E2 is a reference of a class. Understood? Where are we? Yeah. Coming here, we're talking about reference of a class, right? This is something good. So we are going to use already existing instance and then assign it to another variable. That variable becomes a reference variable. Okay. The E1 address is going to share with the E2 instance, right? Now try to modify X value by taking same examples. We'll go to the back here, right? Okay. Now try to do this. The first variable. Let me comment that. Okay. Okay. First we'll see what is coming now. When I print this, right? I'm going to get definitely a same value because not changing anything. Now I'm going to write change the value of X in the E1 instance. When I run this, I still get same value because this is of a reference type, which is sharing with it E1. E1 is sharing with E2. We change E2 also, right? Now it is going to get print, but same value. Understood? As you can see, the changes in made in E2 reference also affect the E1 instance, right? That means whether we made change in E1 or E2, it will affect both, right? This is because of both E1 and E2 are in the same memory. Okay, so using a variables, right? Using a variables of the class, right? So you cannot access the non-static member of a class, but using both instances and references, you can access the non-static, members of the class. This is because of references initialized. Understand? So references do not have their own memory allocation. Rather, they will point to an existing memory, but references are used like instances. Understood? So notice, right, variables, right, of a class, right, cannot access the non-static, right, members of a class. Understood? But using instance and reference of a class, you can access. Understood? So this is all about a reference type because it is always referring to existing instance, right? Here these are the instances, but coming to the reference, this is how we are going to create using already created instance. That way it is going to share the previously instance memory with the newly created E2 instance. Got it? Right? Thanks for listening to this video and please subscribe this channel for more videos. Thank you.